Okay guys, so we went through the first page of notes here last class, and so I'm just going to go right in and start working through the examples with you to keep this video as short as possible. So for example 1, the question is find the indicated nth roots of A. And so again, what this question is asking is which number do I multiply by itself 4 times to get 625. So basically number times a number times a number times a number must be 625. That's really the answer to the question. So it turns out that it's 5 times 5 times 5 times 5. That's 625. So you can think about it this way and just say the answer is 5. Or what you can do is think about it this way and say this is equals to the fourth root of 5 to the fourth power. And use the fact that the fourth root and the fourth power are inverses, so the answer is 5. Same goes for all of the other roots, really. This is saying basically which number multiplied by itself 6 times is 64, and that number is 2. 2 times 2 times 2 times 2 6 times is 64. Or again, you can think about it this way. It's the 6th root of 2 to the 6th, and the root and the power cancel each other, the inverses, so the answer is 2. Likewise here, which number times itself 3 times is negative 64. So in this case, it's negative 4 times negative 4 times negative 4 is negative 64. Negative times a negative times a negative is still a negative. And so the answer to this is just negative 4. If you do it the other way around, it's cube root of negative 4 cubed. And so the cube and the cube root cancel. And again, the answer is negative 4. So either way you want to look at it, you should easily get the same answer. Likewise here, I'm going to approach it this way. It's the 5th root of 243 is 3 to the 5th power. So these go, and the answer is 3. Okay. The next little blurb here that talks about rational exponents, we looked at this last time. We said that if I have something like the square root of 3, the index here is actually 2, and the power on the 3 is 1, and how this works is this is equal to 3 to the power 1/2. So the index becomes the denominator of the power, and the power on the number inside, the radicand, becomes the numerator of the fractional power, the rational exponent. So what they're saying here is just a more general term. If I have a to the m over n, then you can actually choose. There's 2 ways that you can choose to make this look. You can say that I can think of it as taking the nth root. So let's look at the first form, taking the nth root, this is the denominator, taking the nth root of a, and then raising it to the mth power. Or you can first take the nth root and then inside apply the power inside directly to a. Both of these are equivalent, but sometimes it makes problems easier to solve if you think about it in one way as opposed to the other, and we'll do that together. And then here again, just negative exponents. Remember, to make an exponent positive, you just take the reciprocal. So we could actually have an in-between step here. This is 1 over a to the m over n. And then you can apply that rule. The n is the index, and the m is the power that you raise it to. Or you can apply the power first and then take the nth root. So these are your 2 options, but basically very, very similar, except one is a negative exponent. So let's work through these real quick without a calculator. I'm going to show you how this works. So we can say the denominator of the rational exponent is the index. So I can do something like square root. We don't really write the 2, it's understood, but I'll put it there. Square root of 4 to the 5th power. Or we can say the square root of 4 to the 5th power by first taking the power. In this case, actually, it's easier to think about it this way. So there's nothing wrong with the bottom, but I'm going to erase that and just say this is a bit easier because we know the square root of 4 is 2 to the 5th power, and that just becomes 32. It's a bit easier to work with. Likewise here, we could think of this in a few ways. We can think of it as the 4th root of 81 to the 3rd power. And again, in this case, that's actually a good way to go because the 4th root of 81, which number times itself 4 times gives me 81. That's just 3. And then we can raise that to the 3rd power and get 27. Over here we have 9 to the negative a half, like we just said a few seconds ago, 1 over 9 to the 1/2 power. But 9 to the 1/2 power means this is the index, so it's the second root or the square root of 9 to the 1st power. Well, that's just 1 over root 9, which is just 1 over 3. And then finally, we have letter D here. We said last class the nth root of 0 is always 0. The nth root of 1 is always 1. 1 to any power is 1, 0 to any power 0. So what we have here is basically, this is the denominator, so the 8th root, that's the index, the 8th root of 1 to the 7th power. But 1 to the 7th power is just 1. And the nth root, any root, 8th root of 1 is just 1. Alright, then the next example 3 says, evaluate these expressions using a calculator. So you can enter all of this into your calculator exactly how you see it here. I'm going to transition and show you on the calculator what to do. So if you have the TI-84 plus CE like we recommended you to have, there's a nice function here. You go math, and then you go down to the xth root. So that's like the nth root, except they just use the letter x. And basically here you can type in whatever you want. So if we go back and we convert this, this would be the 5th root of 4 squared. So we can do something like this. The 5th root of 4 squared. Hit enter and we get that's about 1.74. So we can go here and say that's about 1.74. But actually we can enter this in the calculator directly like this. That's not a problem either. So if we go back here, we just do basically 4 to the power and put this in parentheses 2 over 5. And what you get is the same answer. Okay? And so let's look at the next one. This is the 4th root of 16 to the 5th power. Again, these things, many of them you don't have to do on your calculator, but we're just practicing how to do it on your calculator. So you can go here, put a parenthesis, go math, and then go 4th root, which would still be the x. Okay, so the 4th root of 16, enter the 16, and then arrow across, close your parenthesis, and raise that to the 5th power, raised to the 5th power. Okay, and so what you get there, if you do that, is 32. Of course, that was not too difficult to do without the calculator. This is 32. We're just practicing to use our calculators. And I'll let you continue practicing that. I'll just tell you the answer that you get here. This one you get approximately 0.0625, and letter D you get about 9.65 if you do it on your calculator. Finally, the last example 4 is solving equations. It says round to the 10th if necessary. So we'll go through here and just apply everything we've learned so far in section 3.1 to solve these equations. So just like we had before, I'll do a different example here. We had something like x squared equals 4 we learned that the way to solve this equation is take a square root on both sides, and when you take an even root you always get plus minus, and the square root of 4 is 2. So very similar thing here, except now we're taking higher roots. So this is a cube root. So if I take the cube root of x cubed and the cube root of 64, the cube root cancels the cube, they're inverse operations. And unlike even roots, this is just the answer. So the cube root of 64, which number times itself? 3 times, gives me 64, that's just 4. Okay? And then, fairly straightforward. Over here, again, we want to isolate the x squared. Fortunately here, the x cubed was isolated. So here we just want to isolate the x squared and then take the square root afterwards. So what we can do here is say 3x squared equals 111, and just subtract this out. So 111 minus 3 gives us 108. And then if we divide the 3 to isolate the x squared, we just get x squared equals 36. And now again, to solve this, just take the square root both sides. Notice that the index here is 2. The index matches the power. That's how you know which root to take. And then we just get x is, now this is an even root, so we must put plus minus. 2 options work, and this gives me plus minus 6. Likewise here, a little bit different. If you want to isolate the power first, well, in this case it's already done. The power has already been isolated. So what we would get here is just go ahead and take the cube root straight away. So if I take the cube root, again I'm choosing the power or the index based on the power. If we take the cube root both sides, we get something like this. The cube root cancels the cube. So I have x minus 2 is the cube root of negative 14. Again, that's not something we really know what it is, just off by hand. We'll have to maybe put that in our calculator. And then what we do is just isolate the x, so we take the 2 over, so we get 2, positive 2, plus the cube root of negative 14. Notice it's an odd root, so we don't do the plus minus like we normally do. And then I just go ahead and put this in my calculator. So let's go over here and see what happens. So we'll do 2 plus the cube root. Now if you hit math, you'll see that there is a cube root already there. You don't have to still mess with it. And then just put in negative 14. You can arrow across, hit enter, and there's the answer. Okay, so this is not exactly equal to, it's approximately equal to negative 0.41. Okay, it's set round to the nearest tenth, so we'll do approximately negative 0.4. All right, so that's what you get if you do that. And then the last example, again, we want to isolate this fourth power. So we go ahead and add 5 to both sides. And we get negative x plus 5 to the fourth equals negative 21 plus 5, 16. That's negative 16. And then what we want to do is divide by the negative 1. And so we have isolated x plus 5 to the fourth power, and this becomes positive 16. Remember, we can't take an even root of a negative number. That would not be a real solution. So what we do here is take the fourth root, so we get the fourth root both sides. So the fourth root cancels the 4, and I would get x plus 5 equals the fourth root of 16. And this is a plus minus because we're taking an even root. But the fourth root of 16 just turns out to be 2 times 2 times 2 is 8 times 2 a fourth time is 16. So this will be plus minus 2. So this would say that x is equals to negative 5 plus minus 2, and that's just two answers. X is negative 5 plus 2, which is negative 3, and negative 5 minus 2, which is negative 7. Alright, and then lastly, just one more example, solve for L. In other words, take this formula and isolate the L, solve for L, get L by itself. So what we're doing here is first just divide by the decimal number in front of L cubed, both sides. This would cancel, and what I have left is W over 0.0167 equals L cubed. And now we know that to undo the cube, we take the cube root of both sides, and that would be the answer. The cube root cancels the cube here, so L would just be equals to the cube root of W over 0.0167. We're not getting an answer here, we're just getting L by itself, solving for L in terms of W. I hope that helped you guys. If you have any other questions, of course, we can address this in class. It's a pretty simple lesson after chapter 2. Thank you.